Greetings, students. This is Miss Trivet from Mathland, and we're working on Chapter 9, Lesson 5. This is our last lesson in Chapter 9. Woohoo, we're getting there. So we're working on page 420 in our green math books, and our learning target today is all about mean absolute deviation. So this one's going to say, I can find the mean absolute deviation of a set of data. I can find the mean absolute deviation of a set of data. So this is going to be a rather short video because to find the mean absolute deviation, there's quite a few steps. So we're going to discuss the steps in detail, and then we're going to do one as a practice, and then you'll have a chance to do one of the on your owns as a practice. Because there's a lot of steps, I don't want to make you do a ton of these. So the top of 420, it says another measure of variation that we didn't talk about yesterday is called the mean absolute deviation. The mean absolute deviation is an average of how much data values differ from the mean. So I'll write down that word, mean absolute deviation. We'll talk about it in words, and then we'll talk about the steps we need to take to find it. So the mean absolute deviation is an average of how different the data are from the mean. And this measure of variation tells us if the mean is a good typical measure of center for a data set. Okay, so talk about the steps. These are big. How do we find the mean absolute deviation? All right, step 1. In our math books at the top, this is where I'm getting this, the key idea section. Also, another way of saying mean absolute deviation, and a lot of kids like this because it drives them mad, is to say MAD or MAD, mean absolute deviation. Doing this over and over drives us mad. So mean absolute deviation. Step 1, we're going to take the list of data and find the mean. And we talked about this earlier on in the chapter. So we're going to do that step with our first example, and then we'll come back to our notes and finish out our steps. So we're going to write the step, and then we're going to do the step, kind of go back and forth. So I'm going to leave some space here, and we're going to start example 1 down below. So we're going to find the mean absolute deviation. Example 1 says you record the numbers of raisins in 8 scoops of cereal. This must be some sort of raisin bran. Find and interpret the mean absolute deviation of the data. So this is the number of raisins in 8 scoops of cereal, just to give it a little bit of context on what the heck these numbers represent. So let's list out our numbers. They give us 1, 2, 2, 2, 4, 4, 4, and 5. So 1, 1, 3 2s, 3 4s, and a 5. So if we followed our steps, remember up here, step 1 says find the mean. Okay, so step number 1. To find the mean, remember we add up all the values and divide by how many there are. So we're going to go 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. And then we take our answer to that and we divide our answer, remember that's my division bar, by how many there are on the list. It told us up here there are 8 scoops, but just to make sure we have 1, 2, 3, 4, 5, 6, 7, 8. So we will take that number and divide by 8. So doing that gives us 24 on the top if you added up all those numbers, And 24 divided by 8 would give us 3. So we've done step 1. The mean of this set of data is 3. All right, let's go back up here. Go back to our color for notes in our vocabulary and talk about step 2. Step 2 says to find the distance between each data value and the mean. So we'll write that down first and we'll talk about what that looks like. Find the distance between each data value and the mean. Okay, well, let's get back to our example color and let's do that work. All right, step 2. Well, our mean is 3, so we can write that down. And then we're trying to find the distance between 3 and each of these numbers. So we're going to create a new list, and this list is going to be our distances. So we need to know the distance between 3 and 1 on a number line. If you go from 1 to 3, you have to hop 2 tick marks. So the distance between 1 and 3 would be 2. What's the distance between 2 and 3? Well, that would be 1. The distance between 2 and 3, again, would be 1. The distance between 2 and 3 is 1 again. The distance between 4 and 3 is also 1 tick mark on a number line. 4 to 3 is also 1 tick mark. 4 to 3 is 1 tick mark. And 5 to 3 is 2 on the number line. So we just created a list of distances between our mean and our original numbers on the list. So that's what step 2 is talking about. Find the distance between each data value and the mean. So we finished step 2. Let's go ahead and write down step 3. Step 3 from our book says to find the sum of the distances in step 2. Find the sum of the distances in step 2. Okay, well, let's go back down here and do that. Oops, let's switch colors here. Let's find the sum of all these numbers. Here's my distances. If I added 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2, we would look like this. And then I would add them together. My sum for step 3 would be 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. That 10 doesn't look very nice. There we go. Done with step 3. There's one last step in finding the mean absolute deviation. So let's go back up here and write step 4. So I found the mean. I found the distance between each data value and the mean. I found the sum of the distances in step 2. And step 4 says divide the sum in step 3 by the total number of data values. So divide by how many values there are. All right, let's go back down and do that. Going back to my green. Oops, we don't want that. Okay, so step 4, I'm going to take my 10 and I'm going to divide it by how many there are on my list. And there are 1, 2, 3, 4, 5, 6, 7, 8. So 10 divided by 8 is going to give us 1.25. If you do that as a fraction, it would be 1 1/4. Let's move that out of the way. But 1.25 would be the decimal version of that. So what does this mean? What is our mean absolute deviation telling us? So our mean absolute deviation is 1.25. So that tells us that each of these numbers is on average about 1.25 away from the mean. That's what it's telling us. So that kind of shows us that these are all pretty close together. They're not very spread out. Remember, mean absolute deviation is a measurement of how spread out our numbers are. So those are the main steps. If you follow those 4 steps exactly like we did here, you should get the correct mean absolute deviation. So now I'll give you the opportunity to try one more. Just in case you do not have your math book in front of you, I'll list out the numbers for you just in case, because I really would like you to try one more. So on your own, at the bottom of page 420, I want you to try to find the mean absolute deviation following the same 4 steps we did here with these numbers. And I'm going to list them for you, so get your pencil ready. Numbers are 5, 8, 8, 10, 13, 14, 16, and 22. So pause the video now and go ahead and follow the same steps that we did up here. Find the mean, then find the distance between each data value and the mean, then find the sum of the distances in step 2, and then divide by how many there are on the list. So go ahead and do that. Pause the video. Okay, so if you tried that, here's your answer. Your answer should be 4.25. So hopefully you got 4.25. If you didn't, I'd like you to try to rework that and try it one more time to see if you can get the mean absolute deviation. And that brings us to the end of chapter 9.